To demonstrate some of the many features 12D has in calculating earthworks quantities, we're going to now look at a typical pad design. In Plan View 1, we're going to create a pad down in this area here. We're going to set the pad up as an alignment string, so we're going to this time use Super Alignment Tools, Create. Under the General tab, we're going to call it Pad 1. The model will be Pad 1 Alignment. The color will be red, and we'll leave the other values as they are. We'll go to the label section. We'll set the label style to no labels, as we don't need labels for our pad. One thing we can do is go to the closure part and we tick on close string. This will ensure that the pad alignment will automatically finish back on the start point. So we click Create to bring up the Super Alignment editor. Firstly, we're going to start off by putting in the horizontal geometry, similar to how we did our road. We use the option Append HOP. We're going to start off by typing in a coordinate. This is done by simply typing 42570 space 36970. We then press enter. In addition to actually typing in coordinates, we can also type it in as a bearing and a distance. In order to do this, we click on B, and down the bottom of the screen now, it is now asking for a bearing. So we type in 90, enter, and it then asks for a distance. And then we type in the distance, 40, enter. So we're just going to continue by creating the edges of the pad using bearing and distances. The next bearing, if we type in B, will be 180, enter, for 15 meters, enter. B, 270, enter, 20, enter. B, 180, enter, 25, enter. B, 270, enter, 30, enter. And then typing in the remaining side, if we go B, we can either type in 360 or 0, enter, 40, enter. Okay, we then press escape. The reason we started along the straight is it's quite a good idea to start where there's not going to be a curve. We now need to define the height of the pad. To get an idea of an approximate Z value, we're going to analyze the terrain in the area of the pad. To do this, we select Tins, Inquire, Height. We're going to select the tin, which is ground, and as we move our cursor near the pad, you'll see the Z value changing anywhere from 64 to 66. So we'll set a height for the pad to 64. So we finish on the panel here, and we're now going to give it a height. To do this, we're going to restore our view, and we're going to look at our long section view. So in our long section view, we're going to profile the alignment string. We're then going to give it vertical geometry, so we go Append VIP. Now because the string is closed, it will only requires one change in height. So if we type in 0 space 64 and press enter, we can then simply press escape, and that's basically given the pad a height of 64. If we wanted to change our vertical spacing, we can click on the menu button, walk right on settings and click grid, and we can change the vertical spacing to say 1 meter and click set, and that gives you a better idea of the actual height. Before we continue, we need to now finish on the alignment editor, as we're going to look at actually manipulating the shape to conform a bit more closely to the existing contours. In Plan View 1, turn on Tin Ground, then click on toggle, and then toggle on tin contours. We're now going to rotate our pad so that it's more parallel to the contour line, and we're going to rotate it at this point here. To rotate an alignment string, we use the super alignment tools, and we go to the option that says rotate. We pick the super alignment using the pick icon. The origin point will be the top right corner, and we're going to give it a rotation, just noting that this is counterclockwise. So we type in minus 40 degrees as we want it to be 40 degrees clockwise. We then click rotate. As it creates a copy of the alignment string, we need to delete the previous one, so we finish on the panel. We then go to the option strings delete, and we simply pick and accept on the old alignment string. We're now going to look at moving the pad or translating the pad. To do this, again, we can go to the super alignment tools area and go to translate. Again, we pick the super alignment. We're going to give it a delta x of 20 and a delta y of minus 30. So we need to move it 20 meters that way and minus 30 meters that way. We again click translate, finish, and again we'll delete the old copy. Strings delete, and pick and accept the old alignment. As the previous two options have created new alignments, if we refreshed our section view, there will be nothing there. So we need to reprofile the new alignment string, and you'll see it there. We're now going to do our first trial run to see how well our pad fits in with the existing natural surface. Firstly, we need to set up the default corner angles for when it creates sections around the corners. To do this, we select Project, Management, Defaults, and the corner angle here defaults to 0. We're going to set that to 15, click Set, then Finish. We're now going to run a function which is going to create our pad batters and interface string. This is done under Design, Apply, Interface. We give the function name something appropriate, which will be pad1. We pick the string interface icon and pick and accept on the edge of the alignment. The cut slope we'll leave at 1. The fill slope we'll change to 2. We'll set the section separations, so every 2 meters along it'll create a section. The search distance will be 100 meters, which is similar to what we saw in the templates. We will be going out to the left hand side. We will be interfacing to the tin ground, and we can give it a model name for the interface, so we'll just type in pad1 space int, and we'll give the section lines, which are called the slope lines, a model name, pad1 sections. The remove loop will take out the sections on the inside corner here. So we click interface, and then we can turn on the model pad1 int and pad1 sections. You'll see here that the angle of 15 degrees is applied to the corners, and on this inside curve the remove loops has taken out what would have been overlapping sections. We can then click Finish and look at some other options for moving the pad around. If we wanted to change one of the corners, in this case we're going to move this corner here back towards the previous corner by 10 meters. We can bring up the alignment editor, edit, pick on the alignment string, and we're going to use the option under the move edit. We're going to use the one that says extend by length. So to pick the correct segment, we pick near number 4 back along towards 3, pick and accept, and we're going to type in a length of -10, enter. You'll then see the corner point move back towards point 3. We can now update the pad simply by recalculating the pad function. If we go to our recalc panel, walk right on recalc and double click on pad 1. And you'll see that the interface has automatically updated based on the new corner position. In our long section, click on the regen button. We can now finish on the editor, and we'll now look at how we can calculate volumes between the pad surface and the existing surface. Now that we have the batters and pad and the interface strings, it's simply a matter of creating a tin of our finished surface to perform the volume calculations. So prior to creating a tin of the pad, we're just going to turn off all the models in Plan View 1 except for the models for the pad. So leave on Pad 1 alignment, Pad 1 int and Pad 1 sections. We're now going to create a tin of Plan View 1. So we select Tins, Create, Triangulate Data. The function name will be tin pad 1. The tin name will be pad 1. And we'll change the color to orange so that when we overlay one tin on the other, it's easy to see them. If we tick on the Data tab and we select View 1, and for the nulling we can pick the interface and accept. We can then triangulate the pad, and in Plan View 1 we can turn on the model Tin Pad 1. Initially we see just contour lines, but if we go to the toggle button and turn off tin contours, you'll see the triangles. We can now perform a volume calculation between the two surfaces. If we finish on the retriangulate tin function, going to do the calculation in a number of ways. Firstly, we'll look at an end area volume calculation similar to the one that was used in the road design. We use the option Design, Volumes, End Area, Tin to Tin. We pick the original tin, which is ground, the new tin, which is pad 1. The angle we'll leave at 90 degrees, and that will basically be vertical sections. We'll set the distance to every 2 meters. The closer the distance between the sections, the more accurate the volume. And we can generate some new sections. So we're going to generate the ground sections in a model called XS ground. The new tin section will be XS space pad 1, and a difference model which will be an XS space diff. The difference color we will change to magenta. We will clean sections beforehand, so that means if we were to run it once, generate these models and then decide to redo it again at 1 meter, it would delete all the data in these models before creating the new sections. We're going to use a polygon, which will be the interface string that we saw previously. The report file will be pad 1 volumes, and we'll use the summary method. We can now click volume. If we scroll down, you'll see the calculations showing the plan area of the interface string, the amount of cut, and the amount of fill. We can then exit the report file.